Hello, Namaskar. So today we'll talk about a very important reaction known as hydroboration oxidation, guys. As we all know that in this series we are talking about organic chemistry for your class 12 as well as for different competitive examination. So today we'll talk about a very important, very crucial addition reaction, that is hydroboration oxidation. So let's jump start it. Just a second. Yeah, I'm sharing my screen. So my dear friends, organic chemistry, as we know that we have many name reactions. But I would like to tell you that whenever you see this C double bond C or any unsaturation for that matter, then you always think in terms of addition reactions. Why is it so? This is unsaturation. This is unsaturation. We have predominantly only 4 categories of reaction. Number 1 is addition. Number 2 is substitution. Number 3 is what? Elimination, and then rearrangement. This organic compound will perform every type of thing what we generally do in our daily life, day-to-day life. So this is unsaturation. I'm not putting H initially, but let me do it for you. So what we can think of that whenever we see that, okay, this is double bonded structure, C double bond C. So C double bond C, generally your mind should be pretty much focused that, okay, now this reaction will give us this electrophilic addition predominantly. Why is it so? Why electrophile will attack? Because we have this high electron density. Electrophile will definitely love the high concentration of electron, and we do have this high concentration of electron here. So what we can say that anytime, anywhere when you see that double bond is there or triple bond is there, so that means an electrophile will definitely attack because of the high electron density. We do have one reaction, anti-Markovnik of addition, that is free radical addition. The mechanism is shared by me. There is a lecture on anti-Markovnik of addition on my channel, but you want it maybe in English. Like today, I'm trying my best to give this lecture in English because many of my students they want me to present this organic chemistry things in English. So I'm trying, my dear friend. So this is what. Let's talk about the hydroboration oxidation reaction. Like we know that hydroboration oxidation, again, this is will be we deal with electrophilic addition type of a thing. So let's start with BH3. Guys, generally we know that BH3 will exist as a dimer B2H6 because BH3 is an electron deficient molecule, and because of this it will form a dimer with the help of a banana bond. Okay, 2 electron 3 center bond. So BH3 will be written as BH32 because the reaction is somewhat like this sort. Now guys, BH3, as we know that in BH3 boron is an electron deficient center. If boron is an electron deficient center, like I said, this reaction is electrophilic addition. So that means boron will behave as an electrophile, and boron will attack either on this carbon or on this carbon. So like you know that in case of addition, if it attacks on this will gain plus charge, and if it attack on this carbon will gain positive charge. Based on the stability of carbocation, the plus on this will be better able to form. So what we can say that when boron attacks, we will get this. B will attack on this because boron will behave and more metallic than hydrogen. So then hydrogen will behave as H minus. So it will form BH2 because of the plus presence of plus on this. H will be placed at this carbon. Going further, what we can say that when we again add this, why is it so? Because BH3 to start with has 3 hydrogen. As we know that 3 hydrogen can be replaced by hydrogen in this case. Look at this. This is simply what? Boron is trading its H minus to get this double bonded carbon. Why? Because boron is somewhat less metallic than the other metal like sodium, potassium. As you move from left to right, the metallic character decreases. And based on the compatibility issue, rather than forming a bond with H minus, it's better to form a bond with C, double bonded carbon, because that will again behave as a base, and B, electron deficient boron, is behaving as an electrophile, or what you can say, this is what electron rich carbon, this is what electron deficient center. Every reaction in organic chemistry will be, you can think about the mechanism in terms of acid and bases. Every reaction is an acid-base reaction. You can easily say that. Maybe you know that there are certain exemption or exception to everything in this world, but you can easily say that every reaction in organic chemistry is all about acid-base. So what you can see, that boron, being an electron deficient center, is behaving like an electrophile, and this is electron rich center is behaving like an nucleophile. So what boron is doing, boron is getting rid of these hydrogens, or rather say hydride, because it is H minus, and trying to form a bond with carbon. Very simple. So these three hydrogen can be replaced, and boron can form these three things. Fine, it's okay. Now going further, we can add H2O2. In organic chemistry, we don't care about the stoichiometry until and unless it is really very important, like one equivalent is added to know that which center is more reactive. So in this case, H2O2 will be added in, like 3 moles of H2O2 will be added. This is near about 6 OH minus. Pretty simple. OH minus is able to attack this boron better than these carbons. So you'll get BOH3. And this carbon will also get this OH minus, and you will get 3 moles of propanol. So let me tell you that the reaction will start as Markovnikov addition, because BH3 attacks on this and will get this plus charge here where H minus gets attached. So initially it starts on the pattern of Markovnikov addition. But in Markovnikov addition, what we get, that the product, the negatively charged, and finally the negatively charged agent or the atom will get attached to this carbon only. But here, this OH is getting attached to this. So what we're getting a product similar to anti-Markovnikov addition. So it starts as Markovnikov addition, but will give you a product of anti-Markovnikovs. Fine. So even in your NCERT or in many test, you will get this. Try to convert propene into propane 1-ol. So pretty easily you can get it done by using this in particular. And this reaction is hydroboration oxidation. Starts at Markovnikov, will give you a product of anti-Markovnikov. Done. So whenever you observe that in any problem we have the C double bond C, just think in terms of electrophilic addition, except in anti-Markovnikov where you can observe that free radical addition will be there. So this is all about hydroboration oxidation in detail. Now we can solve these problems. Guys, I'm running some Zoom sessions parallelly with these classes. If you want to get enrolled in those workshops, we are talking in details about the organic chemistry. And here on YouTube, I'm giving you the details of these name reactions and any other topic you want me to, tell you or to teach. I'm more than happy to do this for you. Okay. So I hope this hydroboration oxidation is pretty much clear to all of you. So next time we will talk about the oxymercuration, demercuration, where the reaction will start as Markovnikov and the final product is, wait and see in our next video. Till then, take care. Please subscribe this channel and please support my cause. Thank you guys. Take care.